Hello, everyone. This is Deva here from our San Jose office, and we have Lucian and Omar joining us for this VideoCoin streaming protocol demo. Both of them will talk in depth about their work. I'll start off with a high-level overview of our protocol, the progress that we've made, and the evolution of the protocol itself as where we stand now in alpha and then where it's going to progress in when we go to beta. Also, we have some really cool new tool that we're working on, which Omar is building. It's called a Stream Explorer. We'll show you the Stream Explorer in preview quickly, and then we should be done with this demo. So there are four main participants in the VideoCoin network: a wallet node, a stream manager, a miner, and a verifier. A wallet node is basically the end user interface to the VideoCoin network, where somebody who wants to broadcast live or create live streams uses the wallet to create a stream, pay miners, and get the VideoCoin mining done. A wallet node looks like this. This is our wallet implementation, which you guys have seen in our end-to-end demo previously. And it comes with a bunch of profile configurations where a wallet node basically sets a device or input. It takes an RTMP stream and outputs it into the VideoCoin network. So in this case, you can see that the RTMP stream it's creating is getting ingested into the VideoCoin network here with the VideoCoin Symphony frontend with RTMP ingest taking it in there. So the wallet is the primary interface for end users to access the VideoCoin network. And from there, there's a stream manager. A stream manager is a trusted node that approves new streams, holds escrowed funds, releases escrows, and also creates creates the smart contracts that are required for the stream manager to function. There is also the miner. The miner does the actual work, picks up the video streams, and then does the work on it. And a verifier performs verification work on the streams that are streamed. So before we get into the protocol details itself, it really helps us to understand how a video stream works. So for us to do that, I have picked up this really popular HLS player. It's called HLS.js. It's on GitHub. I'm going to just take a random stream and start playing it here. And you can see some real-time metrics here. You can see the video that's playing here. But what the player is actually doing is getting a whole lot of chunks from the server. And all of those chunks are getting buffered and then played one after the other. So after a while, you can see that this buffer will collapse. And yep, that's collapsing because all these chunks have already been successfully received. And now you see here only chunk after chunk getting streamed into the network. So this was chunk one. It was probably 10 seconds in length. And then the next chunk, which is 10 seconds in length, comes in. And this keeps happening. So you can go check out HLS.js on GitHub and put any stream in here, HLS stream, and see how HLS streams work. So the VideoCoin protocol itself makes use of this, embeds itself into the way live streams work and creates live. The protocol is interwoven around the way live streams work. So we saw the video, the wallet. You can configure the profile, and then the protocol works like this. So the wallet starts off, loads the private keys of the clients that have. Let me shut off this thing. So the wallet loads the private key of the end user who wants to do the streaming. Gets the RTMP stream. So we saw the RTMP stream in the command and requests the stream to the stream manager. So the stream manager is running on the VideoCoin blockchain with the front end of VideoCoin Symphony that's interfacing to the stream manager. It does a request stream, and then the stream manager approves the stream. Then later, once the stream is approved, the stream manager creates a stream. And as soon as that happens, the end user, the wallet, starts sending an RTMP stream into the network. And we saw the ingest node previously in the wallet screen where the RTMP was ingested. Once the chunks are ingested, the RTMP is also like basically a stream of binary information. Those binary informations are ingested in in the stream manager, those are split into different chunks. So like let's say you have a live football game going on. That stream is basically a stream of ones and zeros that is chunked in file size boundaries, which are configurable in just nodes. Let's say it's 1024 MB for simplicity. So at every 1024 MB, the ingester chunks the input RTMP, registers the input chunk. So like this input chunk is now registered on the VideoCoin blockchain through the Symphony interface. And then as soon as the chunk is registered, a miner knows that that chunk is available for transcoding. And the transcode itself is defined by the profile that the wallet node created when it was creating the stream. And this profile is recorded on the blockchain. So once the miner sees that there's an input chunk available for transcoding, it goes ahead and performs the transcode work. As soon as the transcode work is done, the miner submits the proof, whatever proof it was, whatever transcode of the chunk it just now finished. It calculates a p-hash and takes that p-hash and submits it into the blockchain again as a proof object. And that's when a verifier node kicks in. So a verifier node, which is listening to blockchain events, sees that there's a new proof that's available for it to verify. So it takes the input chunk that was registered by the ingester. It takes the proof chunk that was registered by the miner, compares the p-hash, and establishes whether the proof was right or wrong. If the proof is right, the verifier lets the stream manager know that the transaction needs to be approved. At which point the escrow is released, and a miner gets VideoCoin for the work that it just now performed. So just a little bit more on the escrow is when the wallet node starts creating the stream, it deposits funds into the escrow contract when it was creating the stream. So this create stream call it made is a call that has funds attached to it. And that is where the escrow was held. And then as soon as the stream manager is, as soon as the verifier says that the chunk is ready, escrow is released on that. And then the miner gets VideoCoins for performing the work, and verifier gets VideoCoin for doing the verification work. So this is how, and this process goes on and on for every single chunk, as long as the live stream is available. So as you can see in, so we saw in like the way HLS chunks get loaded here. Every new chunk that comes in, you can imagine that a verifier, for example, this chunk that just came in here, a miner would do transcode work on that. Let's start off with the wallet node. So like the wallet node would send the RTMP for this. The miner node would do the mining on it. And then the verifier node would take the p-hash from the source node and so from the ingest node and the miner's work, compare the p-hash and register whether the chunk was properly transcoded or not. And then in turn, the escrows are released. So as you can see, it's a pretty complex protocol and a lot of moving parts. Lucian will go in more depth on and show you a couple of demos. But before we go there, we'll just see how the protocol will evolve over time. So as of now, the wallet is trust free. So there is, because it comes from, if you own VideoCoin tokens on the network, then you can create streams. The stream manager itself is a trusted entity. So we'll be doing work to move the stream manager from a trusted entity to a trust-free entity. This will be done through proof of stake. And then the miner itself presently does compute mining and submits proofs for compute. But that'll evolve, and then we're already started work on compute storage and bandwidth proofs that are submitted. And also, you might have seen in our in the separate video where we are using ZK snarks to get these verifiers to submit proofs on the blockchain itself. So like these are all happen off-chain. Most high throughput, high intense, high compute blockchain projects use off-chain computing for getting the work itself done. But in our case, in our like we outlined in our research, we're working on using zk snarks to get this verifying the proof on the blockchain itself. And again, the verifier node that you saw in the protocol is also trusted. That'll also transition into a trust frame environment through proof of stake. So this is the overall overview of a protocol and how it works. And then at this point, I'll hand it over to Lucian to go more in depth.
Okay, so I'll share my screen now. Okay, can you see my screen?
Yes, Lucian, we can see your screen.
Yeah, great. So the protocol is currently implemented by a couple of smart contracts, Solidity smart contracts, which are deployed on our live blockchain. We have the manager smart contract, which would be controlled by the manager account or address, and which is unique. And we have the stream smart contract, which models the video stream, and we have one stream smart contract for each stream that the end user would request. So as Deva said, the video stream is split into many chunks. We have a new contract, a new stream contract for every stream. And these contracts act as ledger of the interactions between the different parties involved in the streaming process. The manager smart contract does a lot of bureaucratic work. It holds a list of validators or verifiers, the addresses that can verify the miner proofs. It also manages the stream approval and creation, because the client first has to submit a request with some parameters like a stream ID, an RTMP address, and the required bit rates. The manager account picks up an event and can approve that request. And afterwards, the client goes back and creates that request, and also in that process funds the new stream. We need the funds to award the rewards to the miners. And the streams smart contract basically leaves the manager account out and takes care of the interaction that goes on between miners and validators, and the client as well, because the client can fund the stream later as well if it runs out of funds. The stream smart contract also acts as an escrow. The miners can be guaranteed to get their funds if their proofs are validated, and the client can also get a refund if the stream was done and funds and not all funds were spent. But this needs approval from the manager. So the contracts were developed in Solidity, like with all the standard tools used for Ethereum smart contracts. We used Truffle as well, and Web3.js to create wrappers and interact with the contracts from Node. Now I want to move on to a small demo with Truffle console and the logger tool we previously demoed. Can you guys see my the terminals now?
Yep.
Okay. So I have Truffle console running, and I am going to deploy a new manager contract. So I'm using. So for this demo, I'm only going to use one address, the manager address, to make the calls for simplicity's sake. So I created a contract. I'm deploying it now, waiting for it to deploy. So the network has a 5-second block time. So we should be going in. Yeah. I'm going to take this address to use for the logger tool. Yeah, so now we have a manager deployed, and I'm going to send a request the same way end client would, an end user would, a request for a stream manager. So this is the method. We have a stream ID we previously declared, and this is a placeholder which is supposed to be an RTMP address and an array of bit rates we require. I'm sending the request. We need to wait for it to get mined. So here it is. So this is the transaction receipt. We see a stream requested event coming out with the address, the contract address, and we can also get the client address and the request ID. So now I'm moving on to approve the, oh wait, to approve the creation. These methods can only be called by the manager. So yeah, this also emits an event. We got stream approved. And once the stream approved, or the stream is approved, the client can go on and actually create the stream contract. And the client also needs to send some funds. This is the value parameter we're going to use. It needs to send some funds for rewards. But for demo, we're using the same address, so the manager actually creates it. So yeah, we now have a stream created. So I need to cast that. I'm going to take the address of this new stream. We can also see the events coming out in the logger. So I'm going to take the address of the new stream. And yeah, and cast that into a new stream contract instance. And now the manager is going to add new input chunks as they become available. And then the miners can, once this is done, yeah, we can see an event. This event input chunk added is picked up by miners, by transcoders, and then they can submit proofs. And the miner can submit proofs for that chunk. We have the chunk ID here, the bitrate ID, which I sent before, and these are again placeholder values for the output chunk ID and the proof, but we're using placeholders now. So yeah, this should be get mined soon. Yeah, yeah, so we have chunk proof submitted. Source chunk, it should also show up in the logger. Block. source chunk. This is source chunk. I don't see it in the logger now, but yeah, it should have been picked up. And from now on, the process goes once the miner has submitted a proof. We have this event going on. Validators listen for this event, and then they send another transactions that are going to validate these proofs. And when that is done, the miner is getting funded as well from the funds that are escrowed in the stream account. And I think this is it for the smart contracts live demo. If Deva, you can pick it up from here, I think.
Great, yeah, thanks. So Omar and Lucian and team have been working on something really cool, which is called a Stream Explorer. So most blockchain projects have a block explorer, right? Like where you can dig deep into a block and see what's going on in a block. But as you could see in the protocol, VideoCoin protocol is extremely complex. And then when we start visualizing the protocol in a block explorer kind of a construct makes very little sense because there's so many moving parts and so many aspects into the protocol. A human cannot necessarily, you saw from the method call solution was making, it's really hard for, let's say, an end consumer or enterprise that wants to look at a stream and track it. It gets really hard if it's the interface that we expose into the blockchain is just a block explorer. So we've come up with a new concept called Stream Explorer. And a Stream Explorer is something that gives you an overview into the entire stream. And as an enterprise or as somebody who's streaming live on the VideoCoin network, you'll get data about your streams that are all neatly organized and visualized in one place. So this is still in preview mode. We're just showing this to you in simulation mode right now again, but this will be available this will generally be available in the near future. We're working on getting this cleaned up and ready for you folks to access. But you see this here, it's no longer, it has some of the familiar statistics of a block explorer, but it's no longer, you're not looking at a block, you're looking at a stream. So this here you're seeing in this account is there's presently one stream going on. So we're tracking one stream. So this is the stream, and every green block that you see here is a chunk. Every block you see here is a chunk, and every green block is a chunk that was mined and verified by the verifier and said it and registered as a valid proof. And every yellow block is either the proof was not registered or the proof was missed or like the proof was wrong or basically submitted and either yet waiting for validation or not going to be validated. So when, and this will, as you can see, as the events progress, every transaction and every transaction that releases an escrow will be available in the similar existing block explorer type fashion. But the really cool thing that Omar and team have put together here is a way to look at the stream itself. And we're looking at ways in which we can even provide overall stream access to the account holders. So like the block explorer itself could be unlocked with a private key. And then once the block explorer is unlocked, you can look at the stream itself and hit play here, and you can see the stream that's going on within your account. So this is something cool also on top of what we already showed. So this is also coming soon, and we're super excited about both this and all our protocol work. So this is it for our demo for today. Please stay tuned to our Medium and Telegram channels for the demos and updates. Yep, thank you so much.